lesson. It's on the unit circle and special triangles. The angles that we're going to be focusing on are 0, 30 degrees, or pi over 6 in radians, 45 degrees, or pi over 4, 60 degrees, or pi over 3, and 90 degrees, which is pi over 2. Okay, those are all special angles that we're going to be looking at. And we're going to take those angles and we're going to apply them in quadrants 1, 2, 3, and 4. And from that, we're going to explore the unit circle. Okay? There is a little investigation on how to use Pythagorean theorem to figure out the side lengths for 45 degrees, or 30 degrees, or 60 degrees. But we're just going to skip the investigation and get right to these special triangles. So the special triangles are 30 degrees, 45 degrees, and 60 degrees. What do you guys notice in common about all three triangles?
They all have 90.
Okay, they're all 90-degree triangles, yeah? What else?
All over 2.
Pardon? So the interior angles add up to 180. That's for all triangles, so nothing new, but yeah, that's still a relationship.
30, 60 are both the same.
Good. That's one other relationship. I wasn't quite getting to that, but perfect. So we have 30, 60, 90, 30, 60, 90. They're just rotated around, okay? Different orientation. What do all three triangles have in common?
Same hypotenuse.
Hypotenuse, yay! Okay, so we have length 1, length 1, length 1. And the reason why, I'll just do a quick drawing. If I have a set of axes, the x and y axes, and I were to draw an imaginary circle around there, okay, the radius from the center of the circle to the outside is always going to be 1. And that's going to help us derive the unit circle. And when you think about unit rates, for example, hour or kilometers per 1 hour, a unit rate is talking about per one thing. So for a unit circle, we're talking about the radius being 1. Okay, so that's one relationship, or many relationships that you guys mentioned, but we'll notice that the hypotenuse is 1 on all of them. Okay, they're all 90 degrees, and we have two triangles that are very similar. Now you're probably wondering, how am I going to memorize these triangles? I'll just point out a few tricks that will hopefully help. So first of all, hypotenuse, 1 for each of them. The second little trick, what's the denominators? 2 for every other length. Okay, and the last trick that I like to memorize is 30 degrees times 3 equals 90 degrees. 30 degrees times 3 equals 90 degrees. So if you're ever wondering where that square root 3 goes, I always pair it with in between the 30 and the 90. Okay, another thing to note is we have 3, 2, 1. 3, 2, 1. I know. What do you guys notice about the 45-degree triangle? Okay, so we have two angles that are the same, which means we have two lengths that are the same. Okay, for 45 degrees, your side lengths, x and y, will always be the square root of 2 over 2, with the hypotenuse of 1. For 30 degrees, we're going to have an x length of square root of 3 over 2, and the third length, if you forget it, what can you use to solve for that third side? Pythagorean theorem. Good. Okay, so you know your hypotenuse is 1, you know your x is root 3 over 2, your third side is a half. Okay? And going to 60 degrees, okay, I just made the correlation, 30 degrees times 3 equals 90, so just make sure you remember it's the square root of 3 over 2, and then the third side would be 1 over 2. So I'm going to cover this up, and you guys can work together. So I'm going to give you guys blank special triangles, and then I'm going to see if you can close book, talk it over, and see if you can remember